Why hello friends, Jen Foxbot here for another edition of Math Mondays, na 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 na, yeah! Alright, so we've wrapped up Algebra 1. Please let me know if there are any topics in there that are still unclear or that you would like me to cover, and I can revisit them after we dive into Algebra 2. Maybe I can work them in. But we are ready to dive into the big picture concepts of Algebra 2. So we are taking our understanding to a whole nother level, which is very exciting. So just like I did with Algebra 1, there are many topics within Algebra 2, and I want to focus on the big picture concepts, understanding what we are doing in Algebra 2, and focusing on the things that are most challenging. So this is a two-way dialogue. I want to hear from you. What is intimidating or scary or unclear in Algebra 2? Please let me know and we can tackle it together. Much less scary and intimidating when you have a math buddy. Yay! And I would love to be yours. Okay, so introduction done. The first topic that we will dive into are linear functions. Woo! Yeah! All right. So no need to be intimidated by the term linear function. A lot of times in mathematics there are these big words or new words, and it's just a way for folks that teach math and folks that do math all the time to talk about these things very quickly. And so I will try and stay away from that jargon. So instead of calling it a linear function, I'm going to call it an equation of a line. That's all it is. So typically we see line equations written like this: y equals mx plus b. In this case, we have two variables, y and x, which can change and take on different values. Oh no, my face is blurry. Oh, right, there we go. So y and x can change and take on different values, and then we have two constants, m and b. This is the general equation for a line, so it can be applied to many specific instances of different types of lines. In this case, the way that it's written, m is the slope of our line, and slope is like steepness. So if we were to graph y and x, this line would be very steep, and this line is not as steep. Think about it like if you were skiing or snowboarding or skateboarding or just riding your bike down a hill. It would be a little scary to ride down a hill that was that steep. That's like double black diamond status. Ooh! Whereas if you're going to go down this hill, it's much more gentle. So when you're just starting off, learning a new sport or something like that, it's a lot nicer to go down a gentle or low slope than it is to go down a steep slope. So that is where m comes into play. It's the steepness of our line. It also tells us which direction our line goes. So if our slope is negative, we are going to have a line that flips its steepness the other direction. B is called the y-intercept, which basically just means it's the point at which our line crosses the y-axis, which is this vertical part of our axis. So in this line, the y-intercept looks to be 0. In this very steep line, it's somewhere down here, and in this less steep line, gentle line-ish, it's just below 0. I didn't draw any tick marks because I just want to give you a big picture sense of what these concepts mean. Cool. Okay, so that is all fine and dandy, but what the heck is this? F of x equals mx plus b? What? It's okay. No worries. F of x is just another way of writing an equation of a line, which acknowledges that our line is a function, or it depends on x. And so we can have the exact same scenario where you have x on the horizontal axis, but instead of labeling our vertical axis with y, we just label it as f of x. These two things more or less mean the same thing, so don't get too caught up in the terminology. You will continue to see this later in higher level mathematics. It's very common in calculus and in other types of mathematics. So I want to get you comfortable with the fact that f of x is just another way of representing the way that we write equations. I also like this terminology because it identifies how the equation works. In this situation, our function has one variable, x. You might see later on f of x and y. And in that case, you might see something like ay plus bx plus c, or something like that. In this situation, we have a function that depends on two variables, x and y. So if you had a equation like that, you would actually need another axis, like that. We live in a three-dimensional world. Being able to deal with two variables isn't too bad. All right, but we're just going to focus on the one variable situation because it's a little easier. I like to start simple and then work our way up. Okay, so f of x means that we have a function of x, and when we want to plot f of x, I also like this format because it makes it very easy to create a table of values, which I mean by we can plug in numbers for x, which we get to choose. We have some control over this. And then we use that to calculate what the answer is going to be. So let's look at a specific example. And then let's talk about the parts of linear equations, or equations of a line, in more detail. So let's say we have f of x equals 2x plus 4. And let's say that I want to plot this line so that I can see what it looks like. Maybe this is the equation of a slope and I'm about to go skiing and I want to know if it's safe for me to ski. My line is a little crooked, so we're going to try and make that a little bit more straight. So again, we have x on the horizontal axis and f of x. Us good mathematicians will always label our axes so that other folks, including our future selves, can know what we're talking about here. And I'm going to make some tick marks or just lines on the graph. Try and make them as evenly as possible. Note that this is not equally spaced lines, so it's not going to be perfect, but we just want to get an understanding of what's happening. So what we do by creating a table of values is we pick a number for x and we plug it into this function. So let's say we want to figure out what is f of 0. What happens when x is 0? What does our function or our equation equal to? Well, we just plug in 0 for x, and then we solve the equation. It's not so bad. So in this case, 2 times 0 is 0, and 0 plus 4 is just 4. So f of 0 is 4. Another way of thinking of a function is that it acts on something. So it takes an input. In this case, the input is x. We have one input. And the function, it takes that input and it does something to that input. The something is going to depend on what is on the right side of our equation. And then the output is the result of our function. So in this case, our input is 0. The something that happens is that we solve this equation, and the output is 4. We can do this for all different sorts of test values for x. So let's do another simple one. What is f of 1? What happens when we plug in 1 for our x? 2 times 1 plus 4, which is just 2 plus 4, which equals 6. And we can do this for negative values. We could say, what is f of negative 2? Then we're just going to do 2 times negative 2 plus 4. Actually, let's do 2. We're going to get, actually, that did turn out interesting. So negative 4 plus 4, 0. Okay, so f f of -2, where x is -2, is going to equal 0. And then we can take all of these examples and use that to plot what our equation looks like. So when x is 0, we're right here, then f is 4. Oh, look at that! There is our y-intercept. So right off the bat, without even having to do this, there is some useful information we can get by being able to read this equation. So we know if we have just a +4 at the end and our equation is in the form of mx plus b, b is the y-intercept, just like we've solved when x is 0, our function output is 4. Okay, when f of 1, when x equals 1, we get 1 over here and we get 6 as the output. So 1, 2, 3, 4, 5, 6. So we get right here. And then we are going to go negative. When x is 2, f is 0. All right. And so now we are able to draw a line through those 3 points. Technically, you only need 2 points to draw a line. You need 3 points to define a plane, which is a flat surface. But the more points that you can draw, the more clear your line is. And oftentimes when I'm doing this on a piece of paper, a ruler, or some other straight edge is super handy. So the side of a book or something like that. Okay, so now we get the picture of our function. And we can use this to understand how steep our line is. We can use it to compare with other lines. And we can also use it to make conclusions about the function. Cool. Okay, so the one thing that I really want to focus on is slope. So you might have seen an equation for a slope like this. M equals y2 minus y1 over x2 minus x1. So this is a way to solve for the slope. So say, for example, you were given the picture of a line, a graph of a line, and you were asked, what is the slope? Or maybe you were given a couple of points on the slope, on the line, and the question was, what is the slope of the line? Well, it helps to understand what slope is, because sometimes I've been in a test and I've panicked and I forgot what this equation was. But because I understand what slope is, it's okay, because I can derive the function or figure out the equation for slope using my understanding. So slope is really rate of change, or basically how quickly our line is changing over time, how steep it is. The steepness of a slope is going to tell us how fast we are going to move down with everything else equal. If I was on a bike and I was on a very shallow slope, so I'm going to see if I can draw a little bike. Bikes are kind of hard to draw. Yeah, that's sort of a bike. Okay, whatever. It has some wheels and there's a couple lines in there. So if I was on this slope, I'm not going to be going very fast. And we know that because the slope is going to be fairly small. On the other hand, if I had a thing with wheels, something with wheels, and I'm on this slope, I'm going to be going pretty dang fast. So without knowing what the actual slope is for both of these equations, I can tell you information about what is happening. I can tell you that the slope of this line is less than the slope of that line. If I had a line that was negative and like that, it might be very difficult to compare these two lines without any additional information. But if I have two lines that look very different, I can easily tell you which line has a bigger slope. Okay, so again, slope is basically rate of change. And another thing that helps me remember the equation for slope is thinking about it as rise over run. So how quickly it goes up versus how quickly it goes over. So in this case, this line increases very quickly in the vertical direction and not as fast in the horizontal direction. On the other hand, this line doesn't increase very quickly in the vertical direction, but it does in the horizontal, which means this is less steep. Okay, so I'm going to leave it there for now. That's basically the general overview of linear functions or equations of a line. So typically, questions on a test or on the SAT or further down the road, they're going to ask for you to compare different lines, for you to plot different lines, for you to calculate the slope given two different points. So think about what slope means, that it equates to the steepness of a line, and you can use this function format to plot different lines. All right, cool. So please let me know if there's anything that's unclear about what I did here, if you have any remaining questions. And of course, most importantly, please let me know if there are any topics or problems in Algebra 2 that you would like me to cover, and we can tackle them together. All right, thank you very much for watching, and we'll see you next time. Bye!